In this video, we're going to be talking about center of mass. Center of mass is basically the average of your position. So imagine we have three masses on an x-axis. We have m1, which is going to be 2.0 kilograms at x1. We have m2, which is 5.0 kilograms at x2, 1.0 meters. And we have m3 at 3.0 kilograms at x3 is equal to 6.0 meters. Your center of mass formula is going to be the position, where we're going to have the summation of all of your m's times your positions over the summation of all of your mass. So here, if we would to write that expanded, that's going to be m1 x1 plus m2 x2 plus m3 x3 all over m1 plus m2 plus m3. So now we can plug in our values. You get 1.7 meters. Now, for velocity, let's say we have two objects moving on an x-axis. M1 is 4 kilograms and is going to the right at 8.0 meters per second. M2 is 6.0 kilograms moving leftward at 3.0 meters per second. So this we can write as a positive 8.0 for velocity, and for our v2 we have a negative 3.0 since it's to the left. Our center of mass is m1 v1 plus m2 v2 divided by m1 plus m2, giving us 4 times 8 plus 6 times negative 3 divided by 4 plus 6. This is 32 minus 18 over 10, 14 over 10. Our answer is 1.4 meters per second to the right. So our total momentum is still positive. Therefore, our center of mass moves right. What about acceleration? Let's say we have two objects on a frictionless surface. M1 equals 3.0 kilograms. M2 equals 7.0 kilograms. So let's say we have an external force of 40 newtons is going to pull M1 to the right. Now our second external force is going to exert 15 newtons and it's going to pull M2 to the left. We want to find our acceleration of the center of mass of the system. What you do is you take your external force of the entire system. We have 40 newtons acting to the right, and we have 15 newtons acting to the left, giving us 25 newtons as our net. So our total mass is our M1 plus our M2, which is our 3 plus 7, which is our 10 kilograms. Our acceleration of our center of mass is your net external force divided by your M equal to 25 over 10. We get 2.5 meters per second squared to the right. So what we can take away from here is our internal forces between the blocks don't affect center of mass of motion. What we saw was only external net forces mattered. Let's find the center mass of a velocity if we have an object 1 moving to the right with a velocity positive v, and we have an object 2 moving to the left with a velocity negative v over 2. Your center of mass is m1 v1 plus m2 v2 over m1 plus m2. So m1 is staying m1. We have our v, m2, and this time we have negative v over 2. You have m1 plus m2. So that is just going to be your expression. So another thing is you can say if m1 was equal to m2 in this problem, then this would just simplify down to v center of mass is mv minus mv over 2 over 2m. In that case, v center of mass is equal to v over 2 over 2. Then you would have v over 2 times 2, or you would have v over 2 times 1 over 2, and this would be equal to v over 4.